everyone. Thank you for joining us for the fifth episode of our Spotlight on GitHub Advanced Security series, Investigating Code Security with Copilot. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is recorded. It'll be available to view on demand within 24 to 48 hours. With that, I'll turn it over to our presenter. Andy, thank you so much for joining us today.
Hey, thanks very much for having me. Okay, let's get started, shall we? Thank you. Okay, perfect. So, welcome everyone to the Reactor series, and thank you for having me here today. I'm going to just give a little introduction to the workshop, and then, apologies there, went to the wrong slide. And then we'll start to dig in. So in today's talk, I'm going to be covering the topic of security, specifically application security and how GitHub Copilot can aid in this space. Before we get started, a little about myself. My name is Andy Dennis, and I'm the platform and cloud practice lead at Modus Create. And Modus Create is a partner of Microsoft and GitHub. And we're focused on key areas of digital transformation, such as digital operations, product development, and my own area of interest, which is platform and cloud. And this encompasses at Modus everything from security and cloud security and DevSecOps through to DevOps, SRE work, cloud infrastructure, and build systems, including stuff like Bazel and mono repos. So enough about me. Let's look at what we're going to cover today. So I hope most of you on this call have had a chance to kick the tires on GitHub Copilot. If not, Copilot can be thought of as an assistant to aid you in coding tasks. It doesn't replace engineers or DevOps team members or application security architects, but it can help them be better at their jobs. And so you're probably wondering how. Well, it can speed up repetitive tasks. It can help you to generate unit tests and documentation quicker, and also spot issues in your code before they make it up into the source control management system. So effectively before you push it up into GitHub. From a security perspective, we're going to cover a few topics in this 1 hour session, and these include detecting OWASP top 10 style vulnerabilities in our code base. This basically means asking Copilot to help spot common mistakes that have security implications, and then ask Copilot how we can resolve them. Next, we'll look at Copilot's ability to generate whole new files on the fly, and that can aid us too, as we'll see. I'm sure many of you have heard of gitignore files. Well, they can also provide a very simple security layer to our project. And how, I guess you probably wonder, well, we can use them to block the types of files that often have secrets in them from accidentally being committed to GitHub and pushed up to the repository, because that's always a pain when you have to then go through and clean them up afterwards. And then finally, we're going to look at how Copilot can be combined with GitHub Advanced Security to take a layered approach to reducing our code's attack surface. We'll also look at a new feature currently in beta called autofix. So let's quickly move on and make some basic assumptions about you, the audience. So we're going to assume if you've signed up to the event, you have a basic understanding of GitHub. This includes forking repositories, cloning code, creating pull requests, and similar. You don't need to do them during the presentation, but you're more than welcome to after, and we have a repository which we'll be sharing. I had set it to public, but I had to switch it back to internal for the presentation just to allow the autofix feature to be enabled. But afterwards, I'll switch it back to public, and you're more than welcome to clone it and experiment with it. So if you just want to watch and see how Copilot can be an aid, that's completely fine too. You don't have to experiment afterwards. Secondly, if you join this call, we're also going to assume you have some flexibility and desire to try new tools and techniques. And perhaps your team has already started using Copilot, but you're looking for novel use cases. Or perhaps you've heard about Copilot, given it a quick try, but you'd like a more pointed example of how it can be useful. And in either case, this talk should be for you. And with that, let's dive in. We're now going to run through a basic introduction on improving SDLC security and how the IDE and local development environment can aid you in this. So when it comes to security in the SDLC and using your IDE, more generally our local development environment, so if you think about your laptop, there are a number of techniques and approaches we can take. These include adding third-party plugins to the IDE, and there's commercial products out there, which I'm sure many of you experimented with, and then open source tools as well, like HaruSec, for example. We can also use static analysis tools locally and run secret scanning tools on the command line. We can use pre-commit hook libraries such as Talisman, which are great in this area for preventing secrets, for example, from being pushed up the repository. And then, of course, there's also CodeQL. GitHub Advanced Security is underpinned by the CodeQL technology, and you can install that actually in your IDE as well if you're using Visual Studio Code as a plugin. In addition to running it via actions within the browser, you can build those databases from your code base using the command line tool and then run the query packs locally as well if that interests you. But more than this, we can also use GitHub Copilot. We'll sort of see how that works by using it to detect and remediate vulnerabilities in some example code. Okay, so OWASP Top 10 is a great place to start in finding examples of typical security vulnerabilities that pop up in applications or classes of vulnerabilities. We use the current top 10 to generate some example problems and have put together a JavaScript file containing these in the GitHub repository that I'll share and I'll demonstrate shortly. Initially, we used these in a talk we were doing at a B-Sides event and had actually used ChatGPT to generate these just to demonstrate an example of the types of issues that might pop up in code bases. And we'll quickly run through the types of issues we've selected for this workshop and just a quick overview of the OWASP Top 10 for anyone who's not familiar with it. So I'm sure many of you have heard of the OWASP Top 10, but for those who are new to it, in many ways, it can be seen as an awareness document of the types of issues we typically find in the application development process from a security angle. Many companies use it as a basis for designing an application security standard or driving best practices within their AppSec program. And for those interested, OWASP also publishes the Application Security Verification Standard, which provides the outline for testing web app technical controls. It also provides a list of requirements for secure development. And this is all open source, and you can go out and check it out. You can also find on their website other types of standards, the DSOM and similar, which can be used to aid in improving the SDLC, whether it's from a DevOps perspective or an application security perspective. So if you take a look at the link on this slide, feel free to click that and go check it out when you have time. For this demonstration, we selected issues that fall into the following categories for illustrating the power of Copilot. So the first one is cryptographic failures. Failures in code bases related to implementation of secure libraries or a lack of cryptography typically fall within this area. Then we have security misconfigurations. This covers a range of issues such as default accounts and passwords being in use, error handling, dumping sensitive data to the browser, or enabling unnecessary features which perhaps haven't been particularly well tested and then can be leveraged by a threat actor. The third example here is injection vulnerabilities. And here we find issues such as unsanitized user input, which can exploit SQL injection vulnerabilities. And we have a particular example of this, which is quite fun to work with. Next, we have broken access control. These are problems which occur when users have access to data they shouldn't through perhaps weak access control mechanisms that are buggy and can be bypassed via the browser or URLs or similar. And then we have weak authentication. And this area really covers failures related to weaknesses in the code base that allow attackers to exploit brute force or credential stuffing or missing MFA perhaps on the application. So I'm going to switch over to the IDE and demonstrate how Copilot can detect these issues. So it is now demo time. So I have a little program that we put together for demonstrating how Copilot can help here. This is located in that source control repository, which we will make public after this. So we're going to demonstrate using something we created called vulnerability.js or vun.js, which I'm going to load up here. So the first thing we can actually do is just taking a look through this. I annotated the code with some examples of different security issues, but we can use Copilot to help us do this. So I'm going to actually select all of the code in the IDE. And hopefully you can see this, and I will make it a little larger just for the benefits of the folks who are watching. And then we can ask the chat window for help. So in this chat window here, I'm going to ask it a question, which is list the vulnerabilities in this file. So I've copied in this prompt here. So this is a zero-shot prompt. We haven't given it any specific examples. We've asked it quite a broad question. So let's see how Copilot Chat does when we ask it. Now, hopefully, you should see here a fairly detailed response. And it has some specific examples in here. So the types of issues we annotated and some examples of code as well, which is vulnerable. Now, in addition to the ones that I've highlighted in here, we can see some other things that's come across. So we can actually see Copilot can actually help us to remediate these issues as well. And we'll look at that shortly. And we can kind of think of Copilot in this way as like a SAST scanner almost that's helping us, or a security architect who we're working on the file with, co-programming with. And one of the great features of this as well is that throughout the whole of the development process, we can tap into this and ask questions which become chained together. And I'll show you a little example of how we can do that. So we've seen here, I've got a file, a number of security vulnerabilities in it, and the results from asking a simple question are quite comprehensive. So let me just move back to the slides quickly and we can discuss each of these findings. So great, Copilot found a bunch of issues with the code, but how do we go about actually fixing them? I guess that's the important question. During the demo, we'd found several classes of issue in there. Some of them had a comment highlighting them, as you saw. So you could argue maybe Copilot used that when we were looking at the results, and it saw there was a comment in there and used that to say, hey, this is an issue. But actually, if you drill in a little more into what Copilot returned, it's returning more than just echoing out that the issue was annotated as being an OWASP top 10 problem. Actually, it sort of goes into a bit more detail there. So Copilot wasn't just repeating the comment verbatim. What we can do is when we select issues that it detects, we can ask it further questions and it will drill in further. But what's interesting as well is it found things that I hadn't specifically annotated. In this particular case, the insecure direct object reference, the data exposure, the use of debugger, the network communication, and the cookie handling. So that's just some simple examples we had there. And there's a question: how does Copilot compare to ChatGPT? I.e., how different would the output from ChatGPT be? Great question. Copilot is trained effectively on code bases. It's not for use in a natural language setting. So a question like that, you may get fairly similar answers, but if you try to go beyond that and ask it more natural language related questions, ChatGPT simply won't be able to do that. It's narrowly focused on code bases, so it's very, very good at addressing that, but not more general language questions around perhaps information security in general. So if anyone has any other questions, please post them away. So we've just seen a few issues here. I've demonstrated how ChatGPT detected them. We can also see how it can fix them. And I think that's the important part of the demonstration today is how do we go around and remediate vulnerabilities that are found. So we're going to do another quick demo. I'm going to switch back to the IDE again. Right, so remediating the issue. We can now use Copilot to fix the vulnerabilities in the code base, and we can use a variety of features within Copilot, and they range from the / commands, such as the /fix command, which I'll show you momentarily, or simply asking it questions, pointed questions. Additionally, as we use the chat window on the left, so this is the one down here, you may notice that Copilot will suggest additional questions. So, for example, Copilot may ask you, if you're curious on how to do X or Y. In this particular case, what we see here is what are some of the best practices to mitigate the security vulnerabilities mentioned in the code. So this has actually been posed by Copilot as a follow-up question. We can actually click on this, and it will then go off and do its thing, and it's going to return some recommendations. So in this particular case, we can see it's made some recommendations around fixing the constructor, the get default user, and you have to give it a moment, obviously, to generate these results. And if you push too many or too much context into the question, you may hit the token limit. So just be aware of that, which I can show you in a moment, the token limit. So we'll just let this do its thing momentarily. If you're curious about the token limit, so we can say, what is your token limit? And it's going to come back and it's going to tell us that 4096 tokens is the total input, so the maximum limit. But this code file fits within that. So how about if we have a particularly pointed follow-up question? There is a SQL injection issue, we know, hidden away in here. So I'm going to ask it a particular question around that. So let's target this particular part of the code base. Now, once again, we're going to get a fairly extensive explanation on how to resolve the issue. We've got a code snippet here, an example. Now, of course, I would always recommend, if you're going to use that code, review it. This isn't a substitute for expertise, engineering expertise. Really think of it as kind of an assistant, a pair programmer, a guide who can help speed things up or narrow down what you're trying to do, but not an autopilot, effectively. Okay, so we've got a pretty extensive answer here. So if we wanted to, we could use that code as a starting point to refactor our JavaScript to be more secure. We can now try asking Copilot using the inline chat, for example, how we'd fix parts of the specific parts of the code base. So I'm going to start up here with the constructor. So we can see I've made a note here that this has a particular issue associated with it. So I'm going to select the constructor. Now, for those of you who are unfamiliar, the quick way to get to the inline menu, if you're not using the shortcut or the little star icon, which I'll show you momentarily, is to go to the Copilot menu, and then you can click this Start an Editor. As a contrast to the chat window on the left-hand side, this is the inline question box where you can pose questions to it around how do you do X or Y. So I'm going to ask it, how do I fix the security issues here? We'll give it a question mark. So how do I fix these issues here? So to fix the issues in the code, it says I would replace the plain text password storage with a secure hashing algorithm and add input validation to prevent SQL injection attacks. So we can actually say, we can do a couple of things here. We can discard it or we can accept the change. If we don't like it, we can actually regenerate the change as well. Can't quite see the icon on here, but this would be it here. So if you want to try again, you could click this. If you think it's a helpful response, you can click this, or if it's unhelpful, you can select the down thumbs. But I'm just going to say, yes, that was good, and we'll just accept this for now. So in this particular case, it's updated the password, this .password to use bcrypt, and it's going to hash the password. Now, we've got some duplicate code here, so I can just go ahead and delete that and clean that up. Now, there was a question, can GitHub Copilot be used outside of an IDE, like a web browser? And the answer to that is yes. If you are using code spaces in GitHub, you can actually spin up the code space from, say, your main branch and install the plugin, the Copilot plugin, and then you can use Copilot in the browser visual code editor in there. So you don't have to install the plugin locally into any of the supported browser IDE, sorry. You can use it up in code spaces. So I hope that answers your question. So I'm going to save this change, and we can now move on and take a look at some of the other things it can do. You may notice that it was using the fix functionality to actually change this. So when you pose a question to Copilot in the editor, if it's a fix, it will discern that and use the equivalent of the /fix function. That is very much the equivalent of just doing this, though. So you can see if I've done fix here, what it's done is it's to solve the problem, I'd add the missing import statement for the bcrypt module and remove the unnecessary comment. So in this particular case, we hadn't included the import for bcrypt to be able to then encrypt the password. So it's saying, hey, go ahead and add this in. So I can accept this. Cool. So this is a pretty good starting point. We can accept this fix as well, which I just did. And then we can move on to the broken access control statement and ask Copilot how to fix it. So I have an account class down here, which you can see, and this has some particularly buggy code in it. So I'm going to select the whole of this account class. And we want to figure out how we would refactor it. So I'm going to use the inline chat again. So if I click on this and go back to Copilot and start in editor, I could say, I'm going to copy this prompt that I saved earlier. So Copilot, start in editor. Nope. I managed to paste over it then by accident. Okay, how do I refactor this to be more secure? So Copilot's actually going to come back with a selection of suggestions on how we can do this. So I'm just going to accept these for now so we can see what it did. We can see it made a bunch of changes here. So it is creating a salt for the password, and then it's hashing together the password with the salt using bcrypt. And then it's setting the user's password as the new hashed one. So much clearer. Much better than before, where we had that clear text password just being dumped into the database. We now have a secure password, which is being hashed and encrypted, and it's now being stored. So very simple example there of how we can fix something. So that was very much a toy function though, and the result might not be architecturally the best approach in the grand scheme of things. Really, we'd want to add things like role-based access control here. And if you're using frameworks, obviously a lot of the stuff comes out the box. But we could take a look and ask Copilot, how would I implement RBAC? So that might be an interesting question and see what it comes back with. I'm going to take my prompt. Let's see what it says. So it does a little explanation of what role-based access control is. And it's given us an example here of some code. And I think this is pretty clever. Now, if we wanted to, we could also now ask inline for Copilot to make an update to the code if we wanted to. So I could do something like go to Copilot and start an editor and say, implement RBAC. Oh, sorry. Implement RBAC, and let's see what we get. Okay, so it's made a change here, which we can accept. You can see it's probably going to be pretty similar to what we had on the left-hand side, if not identical. So I think that's a great little example there of how we can do that pair programming, how we can then incrementally improve the code base as we go and add fixes. So what about some of the other things we could do from a security perspective? So if we take a look down here, we can see that there is a stray function, called authenticate user. So if you're doing a review of a code base and you're kind of curious how things work in it, so you think there's a vulnerability within the particular piece of code, perhaps it's legacy code you've inherited from other engineers, and you want to understand, okay, what's this doing if it's particularly esoteric? You can use the explain command. So explain this will kick off a little explanation over here in the chat window. And it's going to give us a synopsis of what's going on. And here we can see that it is telling us that it's effectively doing some authentication. It also is noting here that it's detected some security risks in here. So that's something we can obviously then use to help improve the code base. So another thing, let's have a look and see if it found it. Sometimes when I run this, it notices that the debugger is also enabled in here, which is perhaps not a good idea. So that's the type of thing we can select, and we can say to Copilot, fix this. And it is going to remove the debug module, and it's going to add some cookies in this particular example. And hopefully you can read that. And this fix is going to go line by line through, so you can accept them, you can review and see what it's done. It didn't remove the debugger in that particular case, but it's added in cookies and setting a session. So do check what it's doing as you go. It won't always do 100% what you expect, and that's where the more you get used to using Copilot, the more context you give the questions, the more specific you are, the better it will get, and the results you get will get better. And of course, with it being generative AI, sometimes you get slightly different results between each attempt at prompting it. So we've just seen some pretty simple examples there, and I hope that gives you a taste of what's possible. We're now going to move on to how we can use, say, a gitignore file to prevent things like credentials, transient files getting pushed up into the repository by accident. So that was pretty simple, I think. But what about if we want to prevent a whole class of file being committed to the source control repository? And you may be familiar with this approach, but gitignore files are a great way of doing that. So the gitignore file is placed in the root of our repository. And within this, we can add patterns and extensions and file extensions and paths, which will then be excluded from commits. So this is especially useful if we have a file with credentials in, perhaps that we're using it during the development process to connect to our dev Azure environment, for example. And we're going to look at a simple example of such a file, and it's, in this case, in the repository, it's a .ini file. And in this example, we show why it would be bad for it to be committed to GitHub, and how that simple .gitignore file can be used to prevent that from happening. So I'm going to switch back to the IDE again. Okay, now we're going to create this ini file, and I'm going to show, the ignore file. I'm going to show you how you can do that using Copilot. So let's open up our vulnerable INI file here, and we can see this is full of things that you really wouldn't want to push up to a production environment. So there's a default username and password in here. Hopefully under production system, it's not this. There is HTTPS has been disabled. It's running as a super user. It's logging sensitive information. There's a host of things in here, which perhaps if you're experimenting locally or working in a development environment might be okay, but certainly shouldn't make it into kind of any publicly accessible infrastructure or production system, including things like hard coding API keys in here. That's always a problem if it makes it into the production, if it makes it into the SCM and their production credentials, especially. So let's ask Copilot chat why it would be a mistake to commit this file. And let's see what it says. So there's several reasons it's going to generate. So it can see things like there's sensitive data exposure in here, there's security misconfigurations, we've got some broken authentication in here. There's also broken access control. So not the kind of file we would want to push up to GitHub. Now, if you're curious what a gitignore file is and you haven't used one before, we can ask Copilot that too. So it's going to now tell us what the file is and how it can prevent this INI file from being pushed up to a production system, into GitHub, and then potentially get leaked. So it's giving us a simple outline here of what the file is and the types of things you can add to it. We can now use Copilot to actually help us generate this. So if I go back to Explorer, I'm going to just create a new file using the IDE. So we'll call it gitignore. And if you're curious, another shortcut you can use, and it'll be slightly different on Mac, is I can hit the Command I key here, and that will actually bring up that window. And I can say, create me this file, create a gitignore file contents for me. So an example of how we would do that is add a rule to exclude vuln.ini. So in this particular case, we've given it a file name, but we don't have to just do that. We could also use this icon to pull up here and say exclude all .ini files in this gitignore file. And it's going to go over here. It's added it into chat, which is, we prefer if it added it to the file. You could copy and paste this if you want. And so this wildcard here means that any INI files should now be excluded from being pushed up to GitHub. Of course, it doesn't fix files that are already present. So what do you do in that particular case? Well, that's where manual intervention has to come in. You're going to have to go in. You're going to have to remove the INI file or the key or whatever it may be that got leaked into GitHub from the repository, clean it out, and then go rotate all those credentials. The nice thing is, as you move forwards, though, with that ignore file in, it will prevent those accidental commits making it back up into GitHub. Okay, great. So just going to check if we have any other questions. I think we are good for now. So let's take a look at some of the other features of GitHub beyond just what we've seen in the IDE here. So another one we can look at is autofix. And autofix combines the power of GHAS and OpenAI to detect security issues and recommend fixes. So we can think about, how do we combine GitHub Advanced Security and Copilot? And I think you can all agree that we can see how Copilot can be used to help in the local development process itself. Obviously, we can't be exhaustive today, but it gives you a taster. But how can GitHub Enterprise Cloud and some of the newer features that are coming out that combine Copilot and GHAS be used to help improve our security posture? So GitHub Advanced Security provides a range of tooling, and all that's available directly in the source control management system. And this includes static analysis scans using CodeQL. We can do secret scanning. So we can even generate custom secrets patterns as regexes, and GitHub has an inbuilt AI-driven feature for aiding in this, and I'll show you that. And then we can also do dependency scanning and automatic pull request generation. However, that isn't all. One of the newest features is called GitHub Autofix. This combines Copilot's features and GitHub Advanced Security's features. And when an issue is detected in the code base, the Autofix feature will automatically create a pull request and provide a recommended fix to the identified issue. So we're going to take a look at how this works in a moment. I'm going to quickly switch back over to my browser, and I'm going to show you just some of the features around GHAS, but also specifically that secrets detection tool that I mentioned. So within the repository, if you have a GHAS license, you can go to the settings. And then within this, there is an area called Code and Security Analysis. Now, what we're particularly interested in is the secret scanning here. So I have this enabled. We can actually create new patterns. And what's particularly interesting is that there is this feature here called Generate with AI. And the Generate with AI feature really helps to speed things up in the sense that if you've had to write complex regexes, it can be time consuming, it can be error prone. So I could say, I want a regular expression that does, and then give it a particular example. So I could say detects a private key in the repository. Now, if I wanted to provide examples in here, I could. So if I had a sample key, I could paste that in. And let's just generate the suggestions and see what it comes back with. So no expressions were generated. Please just try again with a different description. In this case, it was perhaps too broad, the question we were asking. Now I'm just going to grab an example perhaps of one of the secrets that were in that vuln.ini file. So I'm going to take this perhaps API key and this is just a dummy one, but I'm going to say write me a pattern to detect the API key in the following example. And let's see if this is, oh, sorry, lost that there. Let's see if it does any better here where we make the example a little more nuanced, we've given it more context. So that's great. So it's actually given us a result here. We can see it's given us a regex. Essentially, it's looking for this combination of alphanumeric characters and symbols, which include the slash. And in this particular case, it's looking for 40 characters. And it will just give me an explanation underneath here of what it's done. And now if I click the use result button, I can now see that we have a secret format specified as a regular expression here, and we have a test string. So it will now go off and it will look for that. Now I'm going to give this just a simple name for today. So we'll call this Microsoft Reactor. And let's do a save and a dry run. Now, this will queue up and it will go off and it will do the dry run. I can paste in that test string that we had from before. So if I take it from the ini file, add it in, we can see the test string's already found one match. So we know that our regex works with this particular string. And this pattern saved and a dry run will kick off. And it's actually going to generate an email and then send me that email with any issues it detects. So it's a pretty clever feature. I can save that now and reuse this as and when I need to for detecting perhaps secrets that have leaked from files into the repository. If you do need to delete it, you can click here and it will kill the dry run as well. But for now, I'm just going to leave this as is. So I'd said we were going to take a look at autofix as well. And we were kind of interested how that works. So let me go to the next part of the settings where we can demonstrate that. So I'm going to go to the code security and analysis screen again, under the codes, and then under the code scanning section, we can see some settings here. Now, in this particular case, I haven't got CodeQL set up, so I haven't enabled the static analysis features in the repository. So what I would have to do is go ahead and select the setup here, and I'm going to choose the advanced option. Now this will generate a out-the-box CodeQL YAML file, and it's going to basically give you all of the boilerplate code you need to go and run the static analysis scan against the code base that we have in the repository. So I'm going to commit this change. Obviously, I wouldn't recommend committing into main without going through your usual process of code reviews and pull requests, but just for the benefits of today, I'm just going to push this in here. This will now create a entry under here. So we can see there's a workflow run. It's in progress. It's going to kick off this scanning process. Now, this can take a little time to run. So I'm just going to switch back to these settings again while it's doing its thing and go back to code and security analysis. Now, if you have access to autofix, you can find it under this section here. And essentially what it's going to do is create pull requests when it detects issues and then annotate those pull requests with the types of problem it's detected, and it can give you some recommendations around it. So while we let actions run in the background, I'm going to create a small Flask application, which we can then use to test the autofix functionality. So save these files. So what we'll do is we'll ask Copilot Chat if it can create a small Flask application for us. So if you're not familiar with Flask, it's a Python-based framework. It's very good for writing sort of lightweight style APIs. Can you generate a small Flask app? So it's going to generate this code for us. You can see this is incredibly simple. And I'm going to copy this code. I'm going to go back to here. I'm going to create a new file. We'll just call this run.py. Oh, apparently I already have one called that. Who did? Okay, great. So we have this here. I guess I already added it in advance. Now I'll just paste this in to make sure. Yep, it was identical what I generated earlier. So this is a very simple application. Now there's something particularly interesting about this in that it has the debug statement set to true. And really, if we were pushing this into production, we want that switch to false. And that would avoid then the risk of someone hitting the web app in production, causing it to trigger an error, and then outputting information into the browser that perhaps contains sensitive information like keys or passwords or similar. So this is our little vulnerable Python file in the sense that it has this debug statement set to true. So let's go back and see if the actions have finished setting up. Fantastic. So here we go. CodeQL is now ready to go. This is the security tab in here, by the way. So when we run scans, any results will get returned under this code scanning section. So if it finds any issues in the code base, it will add them here once we get started. Great, so we're ready to go. What I can do now is go to my terminal window. And if I do a git status, we can see that we've modified these files. I'm going to add just the vulnerable py one. So we'll add source, we'll add run.py. And then we're going to commit this. So adding some Python code. And then we'll just push this up. I hope this laptop is okay. So did that work? The current branch has no, okay, great. Oh, that's my mistake. So I created a new branch just for the demo. I have not done that. Fantastic. So we have now created that new branch. If we do the push, everything's up to date. Fantastic. So I'm going to switch back now to the browser. And let's see, if I go to the code tab, we have a new branch, which is this June 5th demo branch. And if I go to the June 5th demo branch, what we should see is under the source directory, this vulnerable py I added. And this contains the debug statement. So let's go back now and create a pull request and see what happens. So we're just adding some Python code. Let's see if autofix works. So this will kick off now the autofix feature. Okay, and it will take a moment to do this. And you can check the status of the scans under the actions tab if you're curious. We can see that it's still in progress. And if you're interested in how the job works, just click on this and it will, you can see it's analyzing both JavaScript and Python. So when we set this up, we had allowed it to scan multiple languages. And that is available under the supported languages under here. You can set it up. So you can say which languages you want it to analyze. You know, obviously go in here and add in support for more than one language. So we have JavaScript and TypeScript defined here under the matrix in Python. And then it's going to tell it up here, up here to analyze those particular languages, which are detected in the repository. Let's go back to our pull request and see where we're at. So it's still in progress. See the details of this. Okay, so it's getting down to doing the code QL analysis momentarily. Not the most exciting part of the demo, I apologize. Okay, so we can see it's running down here. And we're waiting for it to get to the complete job. Okay, so it's finished analyzing the Python code. Did it pass or fail? That's the question. Fantastic, it failed. And here's why. Because CodeQL was executed against the code base and it detected that we had this debug statement set to true rather than false. And so autofix is able to come along and then make recommendations of how we can actually remediate the issue. So you'll get a description in here. Now, if you wanted to, you could, dismiss this alert, right? Let's say it was a false positive, you could select that. If you were using it in tests, then you could do that. Or if for some reason you weren't going to fix it, that's also an option there. The description of the issue is listed here, and then we have the patch that we can apply down here. So let's just take this example, and we're going to commit the changes, and then it will give us this particular scan again, so it will run scan again, and then we can merge the pull request when it finishes. So we can wait for that to run. I'm sure you can imagine what's going to happen since it takes a moment to do it. And then we would obviously, once it's fixed it, we could pull the code back down again to apply the fix locally. So if you were doing git pull, here we go. We can see it's now applied that fix from the branch up in GitHub itself back down locally, and the debug should now show in the browser as fixed. There we go. So I think you can see that it applied the fix and we're good to go, and I could then merge that into the main line of development. So the conclusion, that was our final demo. Hopefully that was useful. You got to see a few of the features. As I say, it's a lot to cram into an hour, but it should give you a taste of the types of things you can do. And we're going to just do a quick recap and discuss some of the takeaways from today's session. So we covered some basic examples of how Copilot can aid engineering teams making their code base more secure, and also use Copilot as a trusted AppSec advisor. This included demonstrating how Copilot can detect issues in your code, using Copilot to recommend fixes, generating files that can aid in preventing sensitive config files from being pushed up to the GitHub repository. And of course, we could use this beyond just the gitignore files. You could use it to create pre-commit hooks and similar. And we looked at GitHub's newest feature, autofix, and also how we can use that little tiny AI feature that's baked into the secret scanning as well to aid in generating the regexes. So hopefully you've seen some examples today that can apply directly to your own SDLC process. And Copilot, is, just to emphasize, it's not a replacement for security engineers or other tools such as GitHub Advanced Security, but it can be used to complement them. And it can aid in shifting left by introducing security checks and remediation earlier into the development process. Long term, of course, that means code quality should go up in the repository. The number of failed pull requests should go down. You should see a better return on investment through the tooling and a quicker time to market for some of those features if you're not constantly having to fix them or rotate secrets out of the repository and clean them up and similar. So with that said, that's a wrap. Thanks for attending today. If you have any questions, feel free to email me at the above address. If you'd like a copy of the source code or slides or whatever, you can use the QR code above to access the GitHub repository. I know that's kind of feels like a risky click, a QR code randomly on the web, but it should take you through to our stuff. Also, I'm going to make the repository public after this so that you can get access to it, so you can kick the tires on it, play around. And just a reminder, you'll need Copilot licenses and GHAS licenses if you're using, say, GitHub Enterprise Cloud with your company or EMU. Public repository, if you're using that, obviously some of the GHAS features are free to use on open source code. So give it a try. And thanks for your time today, and thanks for joining me. So I will hand it back over to Anna to do the final ceremonies.
Thank you, Andy. And thank you, everybody, for joining. If you have any feedback, we would love to hear what you have to say. You can find the link on the screen or in the chat. Remember to grab that event code. Today's event code is 22657. And we will see you in 2 weeks for the next episode of this series.